To understand what is the difference between all these three. A product layout is that layout which uses the standardized processing operation to achieve a smooth, rapid, and high volume flow. So this is important. High volume flow. On contrary, in the process layout, the layout that can handle varied processing requirements. So here we are using the standardized processing requirement. Here process layout is it can use the varied, that is different type of the process. And the third is a fixed position layout, the layout in which the product or projects remain stationary and the workers, material and equipments are moved as needed. So we have seen while studying the production system. So this was the project type of production system, and this we can have for the different production system we have used. So we'll see in the coming slides how to go into details of product layout and the process layout. So first of all, in the product layout, it is also sometimes called as a line layout or the flow line or the assembly line. So that means the parts are arranged in a line, machines are arranged in a line. Part follows a specified route and the sequence of workstation. That means we will specify the route also. Suppose these are different machines. Okay. So first of all, they are there in a line. Okay. So this is a sequence. But suppose there are many more lines. So from here it will go here and then again here and might be from here again it go to the other machine. So that means a sequence. So a specified route and a sequence of the workstation. It is important which matches with the sequence of the required operations. Third characteristic or the third uh, feature of this type of product layout is that workflow is clear, predictable, and it is easy to control. Operations are arranged in the sequence required to make the product. Like if you want to make a shaft, so say this is a shaft you are making. So naturally, the from the raw material, first we will take the this turning, and then the second turning, and then maybe some other operations. So operations are arranged in the sequence which are required to make the product. This type of layout is used when the operation system must handle a narrow variety of the product. Okay. So the machines are laid down as per the product. So that means the machines, if they are for a car assembly, so that means according to the product. In the car assembly or the car type of production system, we cannot make scooters, okay, or we cannot make the clothes. So like that. So a narrow variety of the product is relatively there and a volume is high. So example of such layout we follow in the car manufacturing, in the paper manufacturing, and in the self-service canteen. Okay. So you see a car is there, a different type of product or a mobile phone you are seeing. So it is this type is designed for a specific product. So if it is for their mobile manufacturing, so you can make only mobiles and that too of very narrow variety. Okay. Then flow lines. So according because it is the material is product is flowing in a line, so it is also known as a flow line type product layout. Sequential arrangement of the equipment. It is important. So the machines are laid down according to the sequence, and the product which are high in demand and the low in variety. Okay. So these are the features. So you see here the raw material it enters at one end. So here the raw material, say it is for product A. So it undergoes step 1, step 2, step 3, step 4 on the different machines, and the finally a finished product is coming out. Similarly, for product B it is there, product C it is there. So that means in the product layout we can make a narrow variety of three type of products which are almost similar. So it is used for repetitive or the continuous processing. So what are the characteristics? So in the product layout, it is a you see a can or a cola bar. So here very fast, high throughput and low work in process. So that means the work cannot wait from one station to another station. And the shorter lead times. So lead times means lead time is that time, uh, the time taken from the raw material to the finished product. Raw material to the finished product. Or you say if you receive an order today and it is say 10th of February and you have to deliver the item say by 10th of March. So lead time is 4 weeks. Okay. So it is suitable for those material which have a shorter lead time. That means faster throughout. And then it is also there for the product which can be automated. That means should be have consistency, and it is specific for a one product. That means the flexibility is very low. Suppose we are making the this Coca-Cola bottle, can bottle, and if we want to shift it to the glass bottle, so we cannot produce it on that same plant. Okay, so that means the flexibility to change is very low. So the characteristics of the product layout, instead of the general purpose machine, we use only the special purpose machine, which are there for only specific operations. Changeover is expensive and lengthy. So that means if we want to change the product, so it will be lengthy and expensive. The material flow approaches continuous. Okay, so that means the material flow is continuous and material handling equipment is fixed. So these are the some of the important characteristics of the product type of layout. So now to we can sum up this up. The very little supervision is required because the plant is automated. Right? The planning, scheduling, and controlling they are straightforward because it is fixed. Once we are fixed for a particular type of product, so every time it will be same. The production time for a unit is very small, so we are talked of the shorter lead time. Then in process inventory is low. So this also we have said low WIP. Equipment that perform the similar processes are grouped together. Okay. And when operation system must handle a wide variety of product in a small volume. That means the flexibility is very small. So it means that if suppose we want to make another cold drink instead of Coca-Cola, but in the similar can of the same volume and the same size, then we can shift with some changeovers. But this flexibility is very small. Okay, so So what we do, if we have to adopt this product type of layout, we organize our departments according to the process. Okay. So you see here, this is a gear section. Okay, this is a drilling section. This is a machining section. This is a boring section. This is a you see maybe a turning section, and this is a paint section. Okay, so we have arranged the machines according to the functions they perform. Paint section, say paint section. Say it is a boring section. It is a drilling section. Drilling section. It is a gear section. Say it is milling section. Milling. And say it is turning. Okay. So the machines are with the similar capabilities and functions. Batch might use the different tooling and the setup and high skill levels are required. So this way we go for the product type of layout. Now, second type of layout is the process layout. So it is a traditional process layout that you see the machines are arranged in a group. Welding is there, turning is there, heat treatment is there, raw material is there, forming section is there, milling section is there. Suppose the raw material goes like here, say from it goes to the forming section, and say from the forming section it goes to welding, and from welding it goes to the heat treatment, and then we get this type of the order. So that means it can go from any section to any section. So that means the machines are laid down according to the process. So in this falls the job shop types. Okay. So traditionally we say the our job shop production is there and it is in the process type of layout. So you see here I have shown a Harley Davidson's and here a musical instrument. So Harley Davidson is made only in small volumes, okay, at the specific order. Similarly, these are also a small volume production. So we can say the variety, high variety and moderate to the low volume. Okay, the volume is very small when they are produced one or two, but variety is more. Not enough demand to the dedicated equipment. So for Harley Davidson, there may not be any demand. So that means the volume of the production will be small. Okay. Similarly here, there can be different type of guitars of the same different size, but their demand may not be very high. Okay. So in the traditional type of process layout, similar processes or the process with the similar needs are located together. Okay. By grouping the similar process, utilization of the sources is improved. Customer, product, patients move through the process according to their need. Okay. So different products, so different needs will be there and the routes will be different. Complex flow pattern in the operation. Okay. So in this case, the example is supermarket because in supermarket you get plenty of items, right from grocery to the entertainment to the medicine, everything. Okay. So that means the flow pattern will be very complex. Job shops, you are making the specific tailored item. So very few, say a tailor shop, or say here we have seen a motorcycle, specialized motorcycle, and there will be the hospitals. Okay, so all these falls under the category. For this, we do the process layout. Suppose in the hospitals we go, so we have a ENT department, we have a surgery department. So we have arranged our departments according to their specific function. Okay. These are the characteristics of a process layout. You see, we have the milling section where all milling machines are there. We have the grinding section. We have the plating section. We have the drilling section. We have the assembly section. And the product can move from any shop to any shop according to the process. So the machines are general purpose. So that means if the milling machine is there, it is a general purpose. It can handle all type of the jobs which can be performed on the milling machine. Changeover is rapid. So if we want to suppose there are two machines M1 M2. So if we want both are milling machine. If we want to change because of some reason this is under breakdown or it is unable to carry that job, so we can go to the another machine. So that means the changeover is rapid. Material handling equipment is flexible. So material handling equipment can be used everywhere. Operators are highly skilled. So that is important. The operator who is operating on the milling section may not be a skilled operator at the grinding section. Or the operator who is working on the grinding machine, he may not be a skilled or a very efficient operator on the milling machine. So you see here the raw material, three raw materials are there, A, B, C. So they are given with a different color. So you see they follow the different route. A raw material goes from 1 to 2, okay. Then 2 to 4, it goes to the machine number 4. Then 4 to 8, then 8 to 10, and 10 to finally it assembles. Similarly, the product B, it goes to 5, it goes to 7, it goes to 11, then 12, and then it goes on. Similarly, the third, it goes to, so you see, all the material cannot be there at the same position. Okay, so you see, they may go on the same machine, they may not go. Okay, so technical supervision is required. Planning, scheduling, and controlling functions are changing because are challenging and changing also. Because every time, suppose this time you have made a say casting, say it is aluminum casting, and it is with some specialized features and all. But next time, if you are going to make a say steel casting, so you will be, of course, you will be requiring the same molds and all those tools, okay, heat treatment shop and everything. But the route may not be same. The planning for the aluminium casting may not be same for the steel casting. The production time is relatively long. When the production time is long, that means the material has to wait. Suppose this product has to go on 6 machine and this product also has to go on 6. So unless and until this machine is free, the other job cannot be taken up. So that means the production time, the waiting time and WIP will be higher in such cases. Okay. Then uh, in process inventory is relatively high. So this is what I was telling. So the production time is high and the inventory is also high. So now if you compare a product layout and a process layout. So I have tried to give you a comparison. So when the workers are concerned, in the product layout, we need the limited skill, while in the process layout, we need the high skill. As far as the inventory is concerned, low in process and high finished good. Okay. In process inventory is low, WIP is low, and high finished good because there is no in process inventory. Then high in process, the WIP is high and the low finished good. Why? Because the production time is more. So when the production time is more, that means the jobs are waiting. Okay. The storage space, a small storage space, and in the process type, the large storage space. Material handling, fixed path, so we may use conveyor. In this, we may use a truck or a forklift or a movable type of material handling which can follow a variable path. Then SIS, these are the working space. So working space are narrow and here the working space are wide because you don't know the casting. It may require a lot many bigger space to store. But in the case of the line type production, the production has to move from one machine to another machine. Then scheduling. Scheduling means we decide at what time this machine, suppose this machine, one machine is there and a job takes say 10 minutes. So if it is started at 3 o'clock, then it will be working till 3:10. But suppose if a job comes at say 3:05, so this cannot be started unless and until this is finished. So that means it has to be scheduled like that. So line balancing type of it is easier, and here it is dynamic and more difficult because waiting times are there, WIP is there. So because of that, the scheduling difficult. Then layout decision. So layout can be inline or layout can be of U type. And here the layout is according to the function. Goal, equalize the work at the E station because it is line type. So we have to equalize the work time at the E station and minimize the material handling cost in the case of the process layout because the need not to move again and again. The advantage, efficiency, it is very efficient type of the layout, and here the flexibility. So we can arrange the machines according to the need. Okay, so it is flexible. So then comes the third type of layout. So it is known as a fixed position layout. And the product remains fixed in a fixed position, and the personals, material, and equipment come to it. Okay. So you see, I have given first example of the ship. So a ship is made first at the shipyard, and the personal and material equipment they are brought, and then it is to pass to the sea or it is put to the channel. It is used when the product is bulky, large, heavy, or fragile. Fragile means the things which can break. So you see here the examples of it is a submarine and it is a ship. The worker is going. Okay. So example for this is home building. There is a land. So the workers go there. The construction machinery goes to the plot and build a house. Okay. Ship, aircraft, building, drilling for oil, all these are under fixed layout type of the. So here also you can see it is a building, some fort. Okay. Here also some construction is going on. So all these are the examples of fixed position layout. So it is normally for those items which are sporadic in demand. So that means low and demand is very low, and maybe after suppose today there is a requirement of making an airport, and next time if you make an airport maybe after 20 years or after 10 years, so like that. So the products are large in size, so very big products. So here you see, and for those products which are impossible to move. Okay, so you cannot make a house in the shop and you can move it to the site. It is difficult. Nowadays it can be made 3D printing you can say, but they are smaller in size. Now the highly customized. So you have to make according to the requirement of the customer. So these are the, I think you can now understand clearly the difference between a process layout, difference between a product layout and the fixed type layout. This is another example of making an aircraft. So it is again a fixed type of layout. So here people and equipment come to the project. Okay. So people are there and the equipment is there and the product is made here and then from here it will be moved. So layout, the goals of layout for the fixed position type is a use space efficiently, efficient personal movement, movement of the skilled people and all, maximum equipment utilization, convenient and a safe working environment. So you see this aircraft is being made. So this shop is very big and the overhead space you can say the extent is very high. Okay. So convenient and safe work movement, simplify the repair and maintenance and smooth flow of work. So these are the some of the characteristics or layout goals for fixed position type of layout. Now you see here we have the different type of production system and we have classified according to the volume of the production, according to the variety of the product. So here you see if the product variety is low and the production volume is low, we go for the fixed location type. If the product quality, product variety is low and the production volume is very high, we go the product layout. Okay, we are making cars, the same type of car, but in the high demand. So we will go for the product type of layout. If the product variety is high, but the volume is low to medium, so then we go for the process layout. And if it is medium, that means the product variety is medium and the production volume is also medium. So we try to follow the group technology layout. So it is another type of the layout, you can say. So what is group technology? So group technology is a technology in which we either make the similar parts together and we call it as a product family, and we make use of the dedicated equipment. So that you see where if we have to do the shaft as a turning, so we'll have all the machines which are doing the specialized turning. Might have the similar routings. Okay, so we can group the parts together and which have the which need similar type of the machines. Grouping not according to the physical experience. Okay, so now you see this is a four type different type of pliers I have grouped. So you see, so we can make a product family because they all are gripping device. So we can say they belong to a same product family. So for making these type of pliers, we may be having the similar operations. So we have a dedicated equipment, so we can just they might have the similar routine, but you see there are some specialized features given in each one of them. Here also, here also, here also. So although by appearance they can be grouped, but it's not the only thing. So they have to be grouped according to all the features. Now one more type of layout is followed, which is a variation of the job type or the product type you can say. So it is a cellular manufacturing layout. We also call CMS, cellular manufacturing systems. Okay, or cellular manufacturing. So when we are talking of layout, so we'll say cellular manufacturing layout. So operations are required to produce a particular group or the family of the parts and are arranged in the sequence of required to make that family. Okay? So you see here it is a cell 1, it is a cell 1, it is a cell 2, you see here is cell 1, cell 2, cell 3. Okay. So this in the cell 1 there are 4 machines, 1, 2, 3, 8. These are 1, 2, 4, 8, 10. In cell 2 there are 3 machines, and in cell 3 there are 4 machines. Okay. So these different routines are given for the particular type of product. So intermediate, it is between the product and the process layout. So wherever the requirements are intermediate, so we go for this kind of manufacturing system. They are used when the operation system must handle a moderate variety of the product in the moderate volume. Okay. So medium volume, medium variety. So what are the characteristics of a cellular manufacturing system relative to the process layout? So equipment can be less general purpose. In the process layout, there can be GPM or the general purpose manufacturing. Material handling costs are reduced. Training periods for the operators are shortened, and in-process inventory is low. The parts can be made faster and can be shipped more quickly. Now, the CM characteristics according to, here we have seen according to the process layout, here according to the product layout. So the equipment can be less special purpose. Okay, there it was less general purpose. So special purpose means they are. It's not like that. If it is a turning lathe, it can do only turning. Okay, so it can do one or two more operations. So it is less special purpose. Changeovers are simplified. That means changing over from one machine to another machine. It is simplified. The production is easier to automate. More than one machine per operator. Okay. Low WIP, that means low work in process, the parts are not getting. Faster response to the quality problems. Okay. So if the quality is not coming up, you can change the machine, you can change the operator, you can change the operations. So it is, that flexibility is there. Shorter throughput time, that means the production time is bit larger. Easier scheduling and control for the machines and for the people. So the last is that just in time. So just in time, as I told, we produce or we order as much as required. So produce and delivering the right items at the right time. Okay. So it is something like this. A order has been received from the customer. So this manufacturer will make only the order for that much of raw material, and this raw material will come only from the fixed supplier. So it is like this. It's not that the raw material is lying here in the store and he takes one and like that. So it is, a process which starts when the just in time. So we need the just in time, and the supplier will. It is just like we order a pizza through Domino's or we order a Amazon item. So if it comes within no time, then it is just in time. Otherwise, it is just in time with some delivery time. Okay. So I think you can understand it. Because the moment you book an order, the restaurant people they make start making the dish or start packing the dish, and the delivery boy takes it to you. So that is the order is just in time, preparation is just in time, assembly is just in time, delivery is just in time. The time to reduce the inventory, it is a technique to reduce the inventory. Use of the resource appropriately, okay, and the flow line is in sequence, so it goes according to the flow. Now, in the summary, we can say here, you see, these are the characteristics, product, process, group, and the fixed position. So this indication is for high, this indication is for low, it is for medium, it is for medium to high, and it is medium to low. It is going towards high, so it is medium to low. We have made it rotated like this. And so these are the charts and these are the techniques. They are being used in that, water production system and total quality management. So all these things will be discussing this in process charts also, where we will be studying the work study and all in the next chapter. So the throughput time is low in the case of the product type of production system. Okay. While it is high in the process system and in group type of layout also it is low. And in fixed position it is medium. Okay. Now WIP, that is work in process, it is low. In process type of layout it is high. In group it is low, and again here it is medium. The skill level which is required, so it depends upon the choice of the product. It is high in the case of process. It is medium to high in the case of group, and it is mixed. The flexibility of the product is low here. It is high. It is medium to high, and it is low. You see demand flexibility in the product case. It is medium. It is very high in the process. It is group, and it is again medium. Machine utilization. So you see in the product line type it is very high. It is you can say medium to low. It is medium to high, and it is medium. Utilization of workers, in this it is very high. In this it is very high. So in this it is very high, and it is medium. Okay. And unit production cost. So it is low in the case of the product type of layout. It is high in the case of process type. Again, it is low in the group type and fixed position. So this way you can compare all the four type of the production layouts. So one more graph. So here the quality is there and number of the different products. So if the number of the different products is low and the quality produced is not very high, then we will go for the fixed position layout, because the things are to be made, equipment has to be taken to the remote place, and if the quality is, if want quality is high, then we have to go for the product. And here if it is more, then we go for the mixed layout, and if it is high, then go for the product. So you see, this way, this type is a cellular layout. So in this, you see, the quality of the it is high here, this layout. So it goes on decrease. Okay. As the number of the products are going on increasing, the quality is low here, but here it is high for the fixed. So this is a product volume and variety graph, and you see in the production flow control, in the product flow control, we can have this kind of uh, batch processing or the flow processing. If we have the batch type of processing, so we follow the process layout, that is from a couple to several thousand identical we can make in the batch. Okay, so we say the you make a batch of, normally we do in the case of the pharmaceuticals, paints. Okay, consumer type of a batch for each different part type. move together through the production system, may split the material handling or to reduce the processing time. So, example you can see, it is important to know in the clothing furniture production, we go for the batch type of processing and the process type of. In the case of repetitive or the flow processing, we go for the product layout and if the products are chemical, food and pharmaceutical, we go for the continuous. If it is car, refrigerator or other type of production like gear production, tire production like that. So we go for the discrete. So this type, so I think you must have made some idea about, so to summarize, we have studied the different type of the layouts, that is fixed type of layout, the process type of layout, the product type of layout, and the as a combination. So in the combination, we have tried to understand the cellular manufacturing system, and the special type of layout we have tried to understand the jet production. So any question from the class you want? So one more slide is there, which talks about the setup cost, which affects the batch size. The cost and time to set up the production facility to manufacture a specific product can affect the batch size. Change over time. That means the setup time, you understand? And suppose a job has to be loaded onto a machine. So you need a fixture, you need the tooling, so you need the setup time or the preparing time. So the changeover time, setup time, the costs are large and the size of the batch is kept large. Okay. So that means we are going to make a batch of say paint or a batch of pharmaceutical. Okay. So we will have one type of the production setup, and then if we are making a different type of the um, uh, medicine or a different type of product at the second time, and with a different batch. So our setup time and the scheduling and planning control all will be different. So larger batch size results higher inventory cost. Sometimes because of the intuition we produce more. Suppose there is an order of say 50 with us. So in the inventory management you understand this how much to produce. So we see that it is economical to make a batch of 80 items, but these 30 items you have to keep under inventory. So if you do not get the order for these 30 items, then the cost of keeping these items, that is inventory cost, this will be higher. So these are the some feature of the batch size. Now production cost, the as I told, one more type of production is there. So this I did not talk to you in the previous lecture because now you can understand it better. So we have make to stock. That means we make and we stock that item. It doesn't matter whether we have the order with us or not. So number of units of each products are kept on hand at all times. Okay. So whether our order is there or not, we produce the thing and we keep in our store. The quick delivery to the customer on receipt of an order. But suppose if the uh, uh, item is there in the stock, so you can deliver it very next day. The way you see, you go to the car showroom and you place an order and you take the delivery. But sometimes, when the demand is more and the production is less, so they are not having in stock. So they make to order. Okay. So in that case, this make to stock is advantageous. So when the delivery response time is a key competitor function. So we produce for such items, suppose a person who is making say camera, okay, Canon is there, Sony is there, and maybe a Kodak, now it is closed, of course. So these three people are there, and if they have made as per MTS, so if they are keeping the item in the stock, so you see they can supply. So the whosoever will supply fast, so he will get an order at a low cost. Okay? Limited number of products manufactured repeatedly. So it is followed for those items when that item is very much there in use. Okay. So it is just like you see in say vest, as underclothes we use the vests. Okay. Or we use the socks. So socks are very common. So they keep on, they know that it will be sold. So it has to be made repeatedly. Then an idea that customer will want. So sometimes we produce in intuition. Okay, just say you see the festive season is there. So you see people go for making candles, knowingly that the people are going to buy. So it is by intuition. Allowed to schedule the production in advance. Okay. So these are the typical characteristics for the make to stock strategy. Another is make to order. So as the name suggests, when we receive the order, we only make at that time. So only produce the item after they have been ordered. The production system must respond quickly. The products have a high degree of customization. Okay. You see, you if you want to get a special made suit, or what you can say, or you want a tailor made printer, or you want a tailor made assembled, get an assembled PC which is tailor made of a high degree of customization. Okay. So he will make only when you see order, and the shelf life of the product is small. Okay. So sometime you see we make the, in the bakery they make the cake, but they make only the limited quantity because they know that the shelf life of that particular item is. And then sometime we assemble to order. So these are again according to the manufacturing type of process: make to stock, make to order, and assemble to order. Sometimes we need not to make an product or manufacture a product. We purchase the parts and we assemble them together. So customer have influence on the design, and they can select the various options from a pre-designed assembly. So it is like this nowadays. This is also known as the modular type of production, where we collect the sub-assemblies and assemblies, and we assemble, like we assemble a computer, or we assemble earlier days we used to assemble the transistors, we used to assemble the tape recorders, and like that. So with this, I think I have tried to cover the maximum I could. So thank you very much for a patient listening. Any questions are there? You are welcome to ask.